The back page here is pretty close to what it was in the packet. In fact, I even used the same mass and height. So I did not do the first step for you. EG equals MGH, and you're going to have 100 times 10 times the height of 10. The 10 is G, the other 10 is the height. So we have a gravitational potential energy at the top of 10,000 joules. And the energy pie chart is all EG. Got a little ahead of myself, but there's no EK and there's no E elastic when we first are at the top of our ramp. The top of our diving platform. We haven't started moving yet, and there's no E elastic because nothing is stretched. So our E total is 10,000. Again, if you haven't done this already, please do it and then use this to check your answer. Don't just do it. Don't just watch and copy. That's not going to help you. So, 10,000 joules of energy total. This is the most crucial thing you have to remember. The total energy, what happens to it? It stays the same. 10,000 is written all the way down here. These all have 10,000 joules of energy. It's so important that you remember that, because if you don't, you're not going to be able to do this problem at all. There's just no way to do it if you don't remember that idea. So the EG at 7.5, and remember height is how far away she is from the ground. Height of 7.5, EG equals MGH. Notice how I always rewrite the equation. I want these videos to be short. I'm still rewriting the equation because it's that important. Mass is 100, G is 10, and this time my height is 7.5. So we get 7,500 joules of gravitational potential energy. The E elastic is 0 here because we have not stretched yet. And so even if you did the whole equation, 1/2 kx squared, you go, okay, my k is 800. What is my stretch? Oh, well, nothing is stretched. So stretch is 0. 0 times anything is 0. So the EK must be whatever energy is left, 2,500. You might be trying to find the velocity and solve for it, but we can't always do that. Sometimes we have to look at the total energy and subtract backwards. So at height of 4.01, same process, MGH. This is going to end up being 5,001 joules of gravitational potential energy. Still no elastic because the stretch is 0. It's 5.001 meters. It's just before it hits here. So our kinetic energy is 4,999 joules, and the elastic is 0. All right, 3 meters above the ground. This is where it starts to get tricky. And this is where we can do EH. That's easy. It's 3,000. EK we can't do. It's the last thing we have to do. And now E elastic is 1/2 times K times x squared. And x is the stretch, and k is the spring constant. So to go through this, our k is 800. It's up in the top of the problem. 1/2 times 800. And then we have to decide on the x value. How much is this stretched? Well, at a height of 3 meters above the ground, go to the ground, 3 meters up, how much has the trampoline stretched? It must be the 2 meters that's left between the top of the trampoline and the 3 meter height. So we're on 2 meters of stretch now. So we put 2 in for our stretch variable, and it has to be squared, right? So we've got 400 times 4, which is 1,600 joules of stretch energy. So how much must the EK be? Well, now we've got 3 energies, but it's still, the 3 energies added up is the E total. So 3,000 plus 1,600 is 4,600, so there must be 5,400 joules of kinetic energy. And I want to note how it still has more kinetic energy than it did just before it hit the trampoline, because it's still falling down. But it doesn't have as much as it would if there was no E elastic. If there was nothing, no trampoline in the way, there'd be 7,000 joules of kinetic energy. So that E elastic takes away from the kinetic energy, and that's what we want. We want to slow down before we hit the ground. If we were going to a pool, we might be okay, but the ground, we need something to cushion us. And our bungee is going to do the same thing. The E elastic will take away from the EK. So at ground level, trampoline fully stretched and is temporarily stopped. Okay, ground level, EG is 0. And is temporarily stopped, EK is 0. So even without doing any other math, the E elastic must be 10,000 joules. But if you did the 1/2 kx squared, you would get that. What's our x in this case? Times 800 times x squared times x squared. X would be Trampoline fully stretched. How much is it stretched out? Must be stretched out 5 meters. It's 5 squared. 25 times 400 is 10,000. So if she keeps bouncing without using any of her own energy, describe what will happen to the energies. What 2 energies will be left when she finally stops bouncing and simply standing on the trampoline? So the default answer is if things just keep going forever, eventually all the energy will turn into heat. There's heat in the springs as it stretches and compresses. There's heat in the air resistance. There's a lot of heat going on. It's all going to turn to E-heat. But what 2 energies will be left when she stops bouncing and standing on the trampoline? Well, she'll still be off the ground. It was only fully stretched because she came in with so much kinetic energy when she hit that stretched it all the way out. But the next bounce, she wouldn't stretch as much. And then she wouldn't stretch as much, and she wouldn't stretch as much. And all that energy, and it would eventually stabilize, and she'd be something down. So E-heat and EG would be all that's left. Thank you for watching the review video. Study, study, study. Come in for help Monday after school, Tuesday morning, Tuesday after school. I'll be available at all those times to help you out. Thanks for watching.